Hi, I'm Ms. Hearn. Let's get started. In this video, we're going to use differentials to approximate the value of a function at a given point. The function that we're looking at is a function of two variables. F of xy equals the square root of x squared minus y squared. If we were to graph that, it'd be in the xyz coordinate system. We'd have z equals the square root of x squared minus y squared. We're trying to approximate the value of this function at the point 5.01, 4.02. Now, the idea here is that this is going to be really close to the function value f of 5,4, but with just a small change in the z direction, right? Because z is the function value. Now, how do we determine how much to add to that value 5,4, or approximate how much to add? Well, how does this differ from 5.01? We're going to add 0.01 to this. This is your dx. Your change in your x, and your change in your y to get to 4.02 is just 0.02. So you can think of that as your dy. Based on that dx and dy, we're going to calculate the dz, the total differential. Now, in general, we have that f of any value a plus dx, comma, b plus dy is approximately f of ab plus dz, and the total differential dz is the partial derivative of f with respect to x at ab times dx plus the partial derivative of f with respect to y at ab times dy. So in order to approximate the value we want, we're going to need to know f of 5,4, that's our f of ab. We're going to need to know the partial derivative of f with respect to x at 5,4. We're going to need to know the partial derivative of f with respect to y at 5,4. F of 5,4 is easy enough to evaluate. We just plug it into our original function. That's going to be the square root of x squared minus y squared, so 5 squared minus 4 squared, which is going to be the square root of 9, or 3. But to evaluate f, the partial derivative of f with respect to x at 5,4, we need to find the partial derivative. So thinking of this as x squared minus y squared to the 1/2, we need to differentiate with respect to x. So we're going to bring the 1/2 out front. We're going to subtract 1 from it, as we always do. But then by the chain rule, we need the derivative of the inside, but it's the partial derivative with respect to x of x squared minus y squared. So this is going to give us 1/2 x squared minus y squared to the negative 1/2 times, now we treat the y squared as a constant, so the derivative of that will be 0. So we just need to differentiate the x squared and get 2x. Now the 2's cancel, and we want to plug in 5,4. So we plug in 5 squared minus 4 squared to the negative 1/2 times 5. And that's going to give us 9 to the negative 1/2 times 5. That's going to be 1 over the square root of 9, or 1/3 times 5, which is 5/3. So we have the value of the partial derivative with respect to x at 5,4. Now let's find the value of the partial derivative with respect to y at 5,4. Here, the only thing that changes is when we apply the chain rule, we have to take the partial derivative with respect to y, so the x squared is a constant and goes to 0, giving us a negative 2y at the end there. And now we're going to evaluate at 5,4. The 2's cancel, we plug in the 5,4, and we're going to have 5 squared minus 4 squared to the negative 1/2 times negative 4, which is going to be 9 to the negative 1/2 times negative 4, which is going to be negative 4/3. So now it's just a matter of plugging in to find our total differential dz. The partial derivative with respect to x was 5/3. dx, remember, was the change in the x value, which was 0.01. So times 0.01 plus the partial differential with respect to y turned out to be negative 4/3. dy, remember, was 0.02. So 0.02. So dz turns out to be negative 0.01. And we're going to add that to our function value at 5,4, because that's our change in the z, approximately. So we get 3 plus negative 0.01 is 2.99. So that's our estimate of the function value at 5.01, 4.02 using the total differential. Now, if we had actually plugged the x and y 5.01 and 4.02 into our function and evaluated it on our calculator, we'd get 2.98993311, which is very, very close to 2.99. So our total differential gave us a pretty good estimate. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video.